also, this is like an emergency panic stop. You can push the
Oh,
button,
gotcha.
and if it's not enough, you can then add the opposite direction. If you're going backwards, you just...
I'm going to put it back to 1% so it's not biased either direction. Or should I leave it the way it is?
Yeah, I'd rather have it not biased in either direction.
Okay, alright. Yeah, it's got its own like 2-second delay in there or something.
That's okay, because now she just takes her finger off the button and it goes away. Let's just
Yeah,
try
you
this.
feel it? It's got like
Yeah,
2 seconds in there. Oops, I hit the joystick that time.
Yeah. Yeah. Hi guys, my name is Tommy Raviel. I've always been a car guy, quote-unquote car guy. I've worked in auto racing, always had a passion for going fast and, you know, evading the police in the appropriate manner.
Okay, try that.
Ooh, that's a nice.
Okay, so, yeah. I see.
All kidding aside, I've also been involved in technology. I've had the good fortune to run across a lot of very, very talented people in my career, one of which is Bo Askew and another one is Matt Uni. So there came a time when Matt and I were talking about a project with this another company who was doing these really cool cars, and they wanted to do an electric car. And it really struck me that, you know, my passion, our passion, is in hot rods. So why not electrify a hot rod and have the best of both worlds? And that's how Watt Rods was born. Yeah, because this is going to be towards the arm, and this is going to be towards the leading edge of the device.
No, I'm connecting. Oh yeah, okay, there we go. There we go.
Yeah, that's perfect.
Here's what I did for the joystick vectoring. Just calibrate the maximum and minimum, but these are all, you see they're nominal. I use pretty even nominal values.
Right.
So that we can easily just drop any joystick in there, you know. Get rid of this.
So we have some really exclusive technology. We have cutting edge stuff, and we want to just go fast and have fun. So in the pursuit of doing that, we realized that there were other things that we can make a difference in other ways. A friend of mine was having a situation with muscular dystrophy, and her disability was keeping her from getting to do the things she wanted to do. And she had a wish list of what an electric chair could be for her and how it would impact her life. So, you know, we kind of put our heads together and we realized there's an opportunity to do something really great for a lot of people in terms of our technology and our passion. Whack, schwack.
There we are.
Come forward, please. Yeah, we got some gription going on. Yeah, we got some gription.
Cool, let's go for a ride.
Yeah, well, we're about ready, aren't we? So let me get this so it's not going to short out anything. So we developed this chair concept whereby someone who has limited capacity can approach a chair with maximum mobility, and the chair doesn't have to weigh like 200 pounds or 300 pounds. We could do it in such a modular fashion where someone who could lift up 25 or 30 pounds could basically snap together a chair and decouple it and throw it in the van and off to the races you go. Because also, myself included, I had knee surgery many years ago and I can't walk long distances, so you know, this really struck a chord. So we figured we have a really cool way of getting around. We have a cool way of increasing people's mobility at a really, really great price with some super, super technology. So that's where Watt Rods has been focusing its time right now, to help the masses get to where they want to go in a really cool way. And this is actually our first prototype. We're here in Matt's shop, and Bo's behind the camera. And we're working out the bugs and getting this thing out for the people to go and have a good time. So that's what we're doing.
Cool, we're ready to roll, huh?
Almost, buddy.
We'll go off the front here.
Sure. Yeah. Straight to the ground. I'm going to take the seat off of it so we don't fall on our butt. Yeah, we're not going to be shooting down the road. We're just going to
tie wrap any of this, you think?
No, I think we're fine. This can't get there, that can't get there, this can't get there.
All
We'll
right.
just hold that in our hand. Do you want to lift it to the ground?
Yeah.
Oh my God, it's nothing.
I think all you gotta do is change the material in the room and we're done.
I think the seat might fall off.
Yeah, this sits in there.
All right. Okay. It's your
All right.
body.
Hope she left us enough room to get out here. See how much mobility this thing actually has, huh?
Okay, well.
And off-road capability too, huh?
I don't know. Let's get it out to the seat.
Highly unstable.
Yeah. Well, it's got no weight on it from the slipping in the gravel.
Okay, just get it on the road, huh?
Yeah, yeah. Unmanned test 1.
Okay, get her back in here for a pit stop.
Yep.
Think so?
Okay.
Yep, see him right there. I'll let you change that. Check that.
Now let me do vectoring. Vectoring is wrong too.
Okay.
Flip vectoring.
Okay, so we're gonna make the vectoring be half of what it is, I guess.
Sure.
Just in the x-axis of the joystick, right?
Mm-hmm.
Maybe that's even too much.
How much of the throttle are you spinning?
Barely touching it.
Yeah, go less.
Okay. Okay. Pit stop complete.
Okay, hold on. Here it is. Let me unplug. And why don't you walk with it first before you sit up with it?
Okay.
You know.
I was confident.
No, that's okay. It's no problem. We'll do a walking test before we do a flying test.
Okay, now we got to try this vectoring a little bit here.
Walk.
Let's see. Well, let's do a little bit here, right?
Yeah.
Okay.
Now we can put race
We always
stripes
need
on.
a logarithmic response. You know what I mean? So you're real sensitive at low speed,
Yeah, and
but then you can still go up to full throttle.
Yeah.
Or the turbo button. Hi, I'm Matt Uni. We're here at my shop. So it's microprocessor controlled electronics, very simple looking prototype here right now, but this allows us to control the vectoring of the joystick and allow precise control movement of the chair. It reminds me of this video I watched on YouTube of this guy that built this 3-wheel T-Rex looking thing and put a turbo Hayabusa motor in it.
Oh yeah, I saw that thing. He was doing donuts in the parking lot. Yeah, that
he
guy's
took
crazy.
off and he did like a double freaking donut.
Yeah.
Oh shit!
Exactly. And more power than he knows what to do with it.
Allows us to customize the response and make the handling the way we want it for the customer.
What are we down to?
20%.
20%?
That's my background. I design electrical control systems, electric vehicles, and this being a very small electric vehicle, a very simple and fun project. Squirrely with it, man. Let's see if I can go in.
See what happens on the flat.
Where?
Right here. Up in this driveway, it's nice and flat. But it's responding in the appropriate directions to the joystick, correct?
Yeah, it is.
Yes.
Engineer's gone wild.
The electrical genius is clowning around.
You gonna try it?
Sure. This is where all the hours in front of CAD either did what you thought it was going to do or not.
Okay, that's why there's that dead band.
Yeah. Boy, it runs backwards a lot.
Need a little more on the theta, and I guess we're probably good on the
Yeah, we need more
the
theta.
X, right?
Yeah, we need more theta for sure. Yeah, I think the joystick has to be more to the response of where you're going and not visual. Like if I'm doing this and I'm going forward and I want to turn, I have to spend less time looking at the thing and more time where I'm going.
Okay, you know, one thing we could do is if the joystick is, if they're within a certain percent, make them the same.
Okay. Okay.
I do that on the boat's auto synchronization. You know, where you usually have 2 throttles.
Yep. Let me see if I can get back to the house.
Well, no, that would just be increasing the deadband in the X. That's what we need to do, just increase the deadband in the X.
Oh, I see what you're saying.
Yeah, let's just double the X deadband.
Okay.
More than the Y deadband. That'll be the steer, huh?
Yeah, absolutely.
Okay, let's do it.
Okay.
Hard riding on the crowned road, though.
It is. It doesn't like the crown at all.
The X deadband.
And go like maybe 50% theta?
Yeah, we're 20% now.
Yeah, let's do 50% theta.
Oh, should we have more theta deadband?
What's the deadband at theta now?
10.
Put it to 20 just for shits and giggles, please.
Okay. Okay, let's go a lot more.
You type in a lot?
Yeah, a lot. Okay. Here you go. You're the driver.
It's working well with some software stuff. We're getting the software stuff sorted out. We're about to sit on the
Well, the software is compensating for the mechanical stuff.
Yeah, Matt's like the software is compensating for the mechanical deficiencies. That's the normal conversation we have in life. All right, I'll call you back later. Love you. That's the normal dynamic between hardware and software. You did it.
Like, make sure you got enough theta now.
Oh yeah. Happy theta person. Look at that. Yeah, the vectoring's not really very happy. It vectors a little bit, but I get a lot more response when I use theta.
This is what, 20%.
Okay. Then that makes sense.
I don't even run that much.
Maybe not. I think the batteries are flat. Because I can't get up this little slope.
Maybe it's an over temperature. Let's feel the heat sink.
Ooh, yeah, toasty. Very toasty.
So it's derating, probably.
Yep. Okay. Yeah, see now, it's responding very well to the commands when it's got no load on it. It is 100% better than what we started with, for sure.
I think we need to...
We might be better off running some cold air past this thing.
It's like if I had a little 5-volt fan, I'd buy something from Marlin. I don't think I have anything. A little computer fan.